Hi, my name is Ayush Agarwal, and today I'm going to be presenting a paper on hurricane trajectory prediction using deep learning. Hurricanes are deadly and destructive storms that cause many deaths and bring billions of dollars in damages every year. The reason is because current weather models are unable to accurately predict hurricane trajectories well in advance. Deep learning, however, holds the potential to resolve this issue. The purpose of this project is to build a machine learning model that can predict hurricane trajectories with high accuracy well in advance using deep learning. So here are a couple of things about hurricanes. They require light wind shear, warm moist air, warm water temperatures of 26 degrees Celsius or warmer, and a cluster of thunderstorms. Essentially all hurricanes are intense bands of rotating thunderstorms. So here are a couple of factors that affect hurricane trajectories. Global trade winds, location of high pressure systems, beta drift, vertical wind shear, and the terrain that hurricanes go over. There are many other factors, however, that affect hurricane trajectories. So here's where machine learning comes in. Artificial neural networks are one of the most common types of machine learning networks. They are used to mimic how the human brain works by creating layers of nodes that act as neurons. The weights between these nodes are used to predict an output from a set of inputs. The objective of the model is to predict the optimal set of weights, which will minimize the loss function. Deep learning uses multiple hidden layers to learn more complex features. An RNN is a special type of neural network which consists of multiple neural networks that are connected, representing each time step, and are used to model temporal data. However, it suffers from an issue known as the vanishing gradient problem, which the LSTM model resolves. The LSTM model resolves the vanishing gradient problem using a forget gate, an update gate, and an output gate, and this makes it an ideal tool for hurricane path prediction. So in this problem, the proposed solution was to design an LSTM model that can predict hurricane trajectories. And this model should also utilize teacher forcing, which is a special training technique which has been shown to achieve faster convergence and higher model accuracy. So the procedure used the basics of 6 steps. First, I collected hurricane data from the ship's dataset. I parsed this dataset and keeping only the desired variables. Then I loaded my dataset and prepared the training, validation, and testing datasets. Lastly, after that, I designed the LSTM model and then trained it for 100,000 epochs. Lastly, I evaluated the model on the test set. Here we can see the number of storms by category. There were a total of 451 storms in the dataset from 1982 to 2017. Here are the number of storms by category and by year. And here are the storms plotted on a map of the North Atlantic Basin, color-coded for each category. So the LSTM model was built using custom LSTM cells in PyTorch, and teacher forcing was used to improve model accuracy and convergence. The parameters used to build this model are listed below. So after training the model for 100,000 epochs, the model had a mean distance error of only about 254.26 kilometers on the test dataset. The training and validation had similar losses as well. Here we can see the losses for training and validation, and as you can see, the model converged after about 100,000 epochs. Notice also that the training curve and validation curve almost coincide, indicating that the model was not overfitting. Here is a similar graph showing the mean distance error for the training dataset while training was occurring. And again, the model converged by the end of training and reached a minimum mean distance error of 263.49 kilometers. So here are a couple of images of the actual hurricane path and the predicted hurricane path. The predicted is in red and the actual is in blue. And we can see the LSTM model did a relatively good job of predicting hurricane paths. Here they're almost coinciding. So to conclude, in today's world with global warming on the rise, it's highly likely that stronger and more catastrophic hurricanes will occur more frequently. In a situation like this, it's critical that we are able to accurately predict hurricane trajectories well in advance. Deep learning has been a useful tool in many problems, and it seems that it can be very useful in hurricane trajectory prediction as well. The LSTM model designed in this study could predict complex hurricane trajectories that involved loops, curves, and landfalls only through the variables around the hurricane. This showed how the model was able to learn and predict how environmental variables affect hurricane trajectories. Still, there's more that can be done for future studies. This model relies on future environmental conditions, so somehow predicting the future environmental conditions and inputting this for the LSTM's future time steps can be a magnificent achievement. In addition, by including environmental data on the entire North Atlantic Basin rather than just near the hurricane, this can help the model identify stronger relationships between the data and predict hurricane paths with a higher degree of accuracy. Thank you.